Yeah, we are recording now. This is session number 2 of the new Scicloj AI Meetup group. And what we'll do today is practice building a RAG. We are 4 people at the moment, Henning and Brian and Nick and Daniel. We'll introduce ourselves and just practice and learn together. And other meetups are coming for anybody who's listening to this recording, which will be shared on the chat. Other meetups are coming roughly every 2 weeks, mostly on Saturdays. We'll have a few meetups with talks by mostly people who have created some existing projects, mostly open source projects in the Clojure AI scene. Yeah, so we will begin. Henning, is it okay to ask that you say something about yourself?
Yes, I am Henning. I live in Norway. I've been in and out of Clojure since 2019, commercially. Java developer in between here. Now back working on Clojure, more or less full time. But I'm an application developer. I'm very new to the more professional part of data science. I have my personal goal is to create I got a book based on Python for machine learning on building the game of Go, a Chinese, Japanese board game. So I'm very motivated to understand how to properly build machine learning and AI components. Trying to learn the fundamentals, learn to understand the basics using Python because it's very accessible, but I prefer working in Clojure. I have a lot of experience with Clojure, but I'm no way professional in it. I've been spoiled working on a world-class application, a couple of fairly known guys here in Norway in the Clojure community for a long time. Created as a consultants, they created a huge web application for my company based on IoT devices on vessels, ferries. I work in public transport. It's a massive code base, very professional piece of code, but so I get to see I get to see real live professional large scale enterprise application, but I haven't developed it myself. I maintain it and I make extensions and I know my way around it. So that's the best I can do.
That's me. Yeah, thanks so much. Yeah, and hello, Ovi. Great. Thanks for making it. Thanks so much.
Hey,
yeah.
Hey guys. I'm not sure if I can stay the entire meeting, but currently the baby's sleeping, so I think maybe half an hour, something like that. So great to see everybody here and like new faces also.
Yeah, Ovi is one of the co-organizers of this new group and gave the first talk we had 1 month ago and now has a new baby. And Ovi, is it okay to ask, that you'd say something about yourself for those who haven't got to know you?
Yeah, sure. So I'm Ovi Stoica. I'm a software developer for about 9 years now. I've been doing Clojure for the last 4 years. Recently, I've been doing a lot of real-time AI applications. So things like, and I did based on this experience, I created VoiceFN, which is like a orchestrator, a library that helps you orchestrate complex real-time AI processors together to make, for example, voice calls with AI applications. But recently I moved that to the browser. One of the other applications for this is conference translation. So if you have a speaker that presents on stage, people could like scan a QR code and get into their headphones the translated stream from that speaker into their own language. So this is another use case I'm currently working on for one of my clients. So yeah, this is basically what I've done. My background is more in web development. I've been doing, before stepping into Clojure, and also within that period, I've done a lot of React Native, so mobile and web development, and now more and more doing AI related projects. And besides that, I'm working on Scicloj, which is a boilerplate to ship Clojure applications fast. So yeah, that's it about me. And I'm very glad to see everybody here. This meetup is it's a place for us to discuss new developments in the AI space, but also get comfortable with existing developments so that we can understand, okay, how is it actually useful? How can I translate this to a real life use case?
Yeah, thanks so much. Yeah. Oh, and another friend is joining. Wonderful. Yeah. So hello, Timothy. We just began, so you haven't lost anything. We did start recording. It is a practice session, and we will continue, presenting ourselves. I'm Daniel. My background is statistics and math. I've been experimenting, making very little experiments with, composing large language models with vector stores and so on. So I may know a little bit about RAG practices, but I'm here mostly to learn and think together.
Thanks so much. Cheers. Yeah.
Oh yeah. And Nick, is it okay to ask that you would say something about yourself? Oh, hello.
Yeah, sure. Hi guys. I'm Nick. I'm originally from Ukraine. Now I'm residing in Philippines. So if you don't mind, I'll turn off my camera after because I don't have good connection. Yeah. So I've been programming 15 years. Yeah. My first programming language was Python. And now I use Clojure and Python. I use Clojure 8 years maybe. Clojure script also. Things like this. I have a little experience in ML. So it's like NLP. Yeah, we built some model classificator. Yeah. And now I'm really interested in ML, AI. Yeah, you try to use different libraries. And now I'm reading AI engineering book. So and what I see I really like, so I want to learn more. Yeah, but I don't have a lot of experience in this area.
That is wonderful. Thank you so much. And maybe Brian, would you like to say something? So wonderful to meet you again, Brian.
Oh, well, it's good to be back. So I'm a longtime software developer. My first exposure to Lisp came with my first job where I worked on Symbolics Lisp machines. If anybody remembers those, which was a hardware dedicated for running and editing Lisp programs. My experience to LLMs is basically on the data side. Most of my work has been essentially working on data pipelines and cleaning the data that goes into these LLMs. So at this point, I am currently unemployed, so I've been trying to spend my time efficiently to get myself to a point where I can gain the knowledge and experience needed to get into that next job. So I really plan to be here more of a fly on the wall, learn, see how people get their work done, get some exposure, and go from there. So
Thank you.
I do Clojure. I've never used Clojure professionally. It's always been a bit of a hobby language for me, just because of my background in both Java and Lisp. So when it came about, I was pretty much aware of it from its very early beginnings. But again, I've never used it professionally.
And you have a friend sitting with you joining us.
Yes. He's had enough attention for now. Now he's just going to sleep next to me for the rest of the day. So.
Oh, sleeping in the session. So yeah.
Yes.
Oh, yeah, that's good. I should do that. Yeah, great. And hello, Timothy. Timothy, would you like to say something about yourself?
apologize. I'm eating breakfast, which is why my camera's off.
Oh, lovely. Yeah, that's great.
Yeah, so I'm a professional Clojure programmer, overall senior programmer for over 20 years now, so quite a while. Clojure programming, I think over 10 years. I've lost track, honestly. I used to be a Java developer, enterprise backend development. Yeah, I had that kind of road to Damascus moment. I was looking for my big thing is I'm trying to find the most expressive way to write programs. And my road to Damascus moment was when I took a double entry bookkeeping system in Java and wrote it in about 1/5 the amount of Clojure code. And I was looking for jobs and work and developing Clojure ever since. So that's been a fun, I guess, progress or journey. And let's see, doing functional programming in the last, I'd say 2 to 3 years. I've always been interested in AI. The last 2 to 3 years, obviously, LLMs have really taken over. I'll taken from perceptrons to feed forward back propagation. Now LLMs are, the sort of language or architecture of choice. And now it's just a very exciting field. And I'm looking to the tools. I'm trying to develop an artificial or an intelligent assistant, excuse me. So I'm just trying to keep up to date with the toolings, especially in the Clojure space right now. So again, I'm just a fly on the wall myself. So yeah, that's me in a nutshell.
Yeah, great. Thank you. Wonderful. So we have all presented ourselves, and now in a moment we will begin the session. We have like 70 minutes to the official time, a little more than an hour. And
no, just okay. It's just
yeah, that's great. Thanks so much, Brian. Yeah, I will share the screen for a moment, and so you see my screen now, my browser. That is the Clojure Zulip chat. That is where we will follow up on topics, on conversations of this new group. You see, we have a channel called Scicloj AI Meetups in the Zulip chat, and under this channel, we have topic threads for these meetings. This is the topic thread for meeting number 2, and here we'll share different resources, and eventually we'll also share the recording internally here in the chat. So here, for example, I'll share the Wikipedia entry about what a RAG is, and in a moment we'll look into that, and so on. So I think a few of us may have run into this notion. And does anybody wish to say something about what that is, a RAG? Conceptually, just the idea.
Well, I've just come across concepts of, I guess, tool use, quote unquote, in LLMs writ large. So an LLM is obviously something that's been trained in, let's say, a laboratory or in some environment that does not have access to the internet or the real world, let's say. So when you add tools to that mix, now the LLM has a tool, which is just a function, right? To, let's say, access your desktop or your machine or the internet to retrieve additional information real time. So the LLM, which is generating text or responses, that generation is augmented by now this additional information, this is my understanding of retrieval augmented generation. So if I've misunderstood or left anything else, yeah, we can certainly adjust that. So.
Yeah, thank you so much. Yeah, so I think to me, this seems, general enough in the way we hope to have at this moment, right? So in other words, the idea is that we have a language model that may have some knowledge included in the language as we know about these models, but we also wish to use our own knowledge to augment the behavior of the language model. So we add knowledge as context for the conversation, basically for the query we're going to pass to the model. And yeah, maybe Ovi wishes to add something.
Yeah, I wanted to ask, I haven't used RAG extensively, but my understanding of it is basically when you give an LLM a concept, like let's say a dog, right? Internally, it kind of represents that as an array of dimensions in a, this might be wrong, but like in a Cartesian space, you can think about it as a coordinate, right? And it's represented as a vector. And you can have, let's say you have a big knowledge base of stuff, like your Confluence knowledge base. You can take all of that knowledge base, and there are specialized models for this. You can get all of that text through an LLM that spits out embeddings. And these embeddings are kind of like vectors. And you store these embeddings into a database, into a vector database. And whenever a user does a query, you create the embeddings, the embedding equivalent of for that query. So that would be like the array of numbers equivalent for the query of the user. And you do a similarity search based on that, the resulting query and what you have in the database, and you get back the context from your, let's say, initial Confluence knowledge base, and you give that to the LLM as additional context so that it can provide specialized information as a response to the user. I might be wrong in many of these things, but this is...
So at least for the common practice that we see in RAG tutorials, in the the usual tutorials for RAG, that is the practice we see that people use. They take the knowledge and usually store it in this vector database, somehow represented as vectors of numbers. So I think our plan for today could be to make that very concrete, just to see that happening. So yeah, really thank you for making it so concrete at this stage. Yeah, and for anybody who is new to the idea, I think it is okay to not grasp all of it at the moment, because we will make it very, very concrete. Yeah, any other thoughts, any comments before we continue? Yeah, great, thanks. So I think our plan will be to pick a little piece of knowledge, maybe a small collection of texts, maybe a big piece of text that we will break into chunks as they usually do, and store that as our own data store using this practice of arrays of numbers, and then have a conversation with a language model where we use whatever we retrieve from our data store as context for the conversation, right? So that's our plan. And this way, whatever we ask the language model will be alongside additional context that will help the model be situated with our actual knowledge, right? So that's, I think, what we're going to do. And maybe one resource worth mentioning is this Clojure Data Tutorials project. It is a new project, still mostly a collection of drafts by our friend Carsten Bering, who is so active in creating these kinds of things in the last couple of years. And you see it has this web page in the GitHub pages with a few existing tutorials. All of these tutorials are built in dev containers, so they can be reproducible, and they are rendered over GitHub pages as GitHub actions. So it is all built to be very reproducible, so people can, use that, reproduce it in their own machines. And one of these little books that Carsten began creating was using LLMs from Clojure. So I'm going into that, and here you see it is this kind of book where we have a few chapters, and we'll jump to chapter 4 about a simple RAG. We will not follow exactly that, but we will use that for inspiration, just so that, you know, we don't have to search for all the relevant classes and functions ourselves. And maybe somebody here maybe already has some experience and will propose other ways to do things. So we don't need to follow Carsten's tutorial. It is just here to keep us kind of safe. And what Carsten did was following another project by Neil Diamant, this collection of RAG techniques notebooks that I'll try to open now. And this repo became kind of famous, got lots of attention recently, and it has this collection of notebooks in Python, of course, right? And it has a simple RAG notebook. And Carsten reproduced that notebook in Clojure. And we will see that what Carsten did is exactly what Ovi was mentioning, you know, this idea of representing text as arrays of numbers and storing these arrays of numbers in a data store, in a vector store, as they call it, right? So that's the starting point. And what Carsten did was mostly using this library called LangChain4j, which is, of course, a Java rewrite of some parts of the famous Python LangChain. Python LangChain is this huge collection of different pieces of functionality that are useful for LLM-based systems. And it is, of course, something which is kind of framework-like, but it is not just about the framework. It is about the functionality, about little tasks that we may need to perform. And there are, I think, really thousands of people contributing to LangChain. And LangChain4j, the Java port of some parts of it, is not as active, but is quite active, and does provide some easy paths for the JVM for certain tasks. And for some of these things, there may be other ways to do it. So we don't need to do everything in the JVM, but sometimes it is easy to know we can find something here. So we will follow Carsten's way, unless somebody here will say, oh no, please let us use another thing, right? So any comments, any ideas so far before we continue? I think I'll share my whole screen now. And this way we'll also see my editor. So you see the whole screen now. There is a little delay of a couple of seconds. And yeah, so we'll keep Carsten's tutorial on the right, on the left, and on the right we'll start creating this Clojure project. So I'll create a deps.eden file with dependencies. And let us use some dependencies here. So going to Carsten's tutorial, I'll go to the bottom of the page where there is the link to the source. And here in the source, let us go to the project definition. And here we have Carsten's deps.eden file. Let us take a few of these. So, Clojure. And Nodge is the data science toolkit. Sometimes it is useful to have that, so let us have it with us just in case. This is now the current version. And let us also pick a few of these LangChain4j dependencies. Maybe PDF is not something we need at the moment. So the main LangChain4j, LangChain OpenAI, and LangChain4j embeddings, as Ovi explained earlier, the idea that we take little pieces of text and convert them to vectors of numbers, right? So I think this is a specific embedding method that Carsten chose to use, and we may follow that. So yeah, I just checked earlier, and now, if you wish to search for the current version of LangChain4j, one place you can search for is the Maven Central. And you see here, we have the central repository of Maven artifacts. So we have this version now, so we can, use the up-to-date version. Hopefully, not many things were broken since this earlier version. So beta 2. Okay. So for now, these will be our dependencies, and I will start the REPL. Oh, I have another one running, so I'll close it just in case. And in a moment, we'll have the REPL running, and we'll create a notebooks directory, which is a common practice where we create some stories of data processing. We usually write closure files in a notebooks directory, and later on we can render them as HTML pages and so on. So let us call it rag.clj. So that will be our namespace, and we can begin. And I think, even before we have some piece of knowledge we may wish to include, let us just look into this practice of turning text into arrays of numbers and storing these arrays of numbers in a vector store. So these couple of tasks, they are quite useful to get used to, and maybe we should begin with them. But maybe we should have some story in mind, some goal we may have, right? So in Carsten's case, it all began with some PDF file. Where was it? PDF. So it was this, some paper about climate change, and Carsten used that as the knowledge base, as the collection of text chunks that was stored as knowledge. And then, that's the kind of knowledge we wanted to inject as context. And we might pick something similar, and maybe in a moment we'll pick something. So should we do that now? Does anybody have any idea of some publicly available text we may use to, to inject as knowledge to our system? Right? The idea is that if we can use that as our knowledge, then we can ask our language model questions about that piece of knowledge.
The Elements of Closure book just became free. We could use that.
Oh,
Lovely idea.
Oh, yeah. So Elements of Closure. Oh, that's amazing. That's amazing. And maybe it hasn't been, learned yet by existing language models. So that's an opportunity to help them out. So we have this PDF file. That's amazing. Great. So we will save that and maybe copy it to our own directory. So right, so we have this PDF file, and right, I really like it. So actually, we do need Carsten's additional dependencies of using LangChain4j to process PDF files. So I'll go here to the code and use these additional dependencies. So again, that's Carsten's source. Here is the dependency. We will add this dependency here. Great, that is great. Yeah, so again, use the more recent version, and I restart the REPL. Right. So here we are now, and let us start looking into Carsten's code and maybe follow a few details of what Carsten was doing. So you see there are those Java classes. Maybe, I don't know if all of us are used to Java and to, importing Java classes. So maybe let us spend some time with it. I think, yeah, we will need this embedding store. Yeah, probably all of these are needed. And the idea is that when we write things like that, what we mean is that, for example, we have a Java class with this name, this long name, because it is a Java class, and Java classes have long names, and the prefix part is called the package, and the actual suffix is the class name, and one way to import it is to write it this way, and then it means that in our code, in our Clojure code, we can refer to that class just by the name and don't need to have all the prefix of the package. So that's what we do when we do these imports at the beginning of our namespace. And now let us maybe play with two of these just to get used to the idea of embedding and storing embeddings. So I think what the two of them that we care about at the moment are these two, right? And one of them is about storing vectors of numbers, and the other one is about turning text into vectors of numbers. So let us try it now. So it is all about this Java interop, this practice of using Java from Clojure. And if I'm doing something which is unfamiliar or strange, please stop me. I think it will be useful for more than one person, or probably most of us, to stop and actually recall how we use Java. For me, it is all, every time I would do that, I need to remember again. So yeah, I think this is kind of the center of the process, just creating these two objects. We have our embedding model and our embedding store. The model is about turning text chunks into arrays of numbers, and the store is about storing and retrieving arrays of numbers and their associated text. So these are the two tasks we care about. These will help us, manage our knowledge. So for example, let us, try it out. So we can use our embedding model. Should we read about this one? What is that actually? Right, so we may search the web for a moment, and right, so it is, as many things, it exists in this Hugging Face collection of AI models, and is it familiar to anybody here? This name of a model, All Mini LM L6V2. What is that? A sentence transformers model. It maps sentences and paragraphs to a 384-dimensional dense vector space and can be used for tasks like clustering or semantic search, right? So it transforms sentences into arrays of numbers. And yeah, here we have the Python examples, and here we have it available in our system through this ONNX system, which is a way to make AI models available in different platforms. As far as I remember, we are using it as a Java library, but there is a C++ implementation behind it, a native implementation, and at least, yeah. And so it is this huge collection of models we can use from within Java conveniently, as if it were all Java, but actually it is not pure JVM. So, right, so we have this model, and we can do something like, following Carsten's code, right? So Carsten did something like embed all. So I think, as far as I remember, it also has an embed function. Embed means turn a piece of text into an array of numbers. So let us do that. Embed. And let us use our embedding model. and have some piece of text. Today is Saturday. So what we got, right? Let us print it. What we got is this Java object that contains a vector of numbers, which is a certain representation of this text as 384 numbers. The idea is that texts which are similar in the content, in the topic, and so on, will be mapped into similar vectors. Usually, these vectors are created as an intermediate representation of those deep networks that perform other more sophisticated tasks. And today we're not trying to understand how they are created, but only kind of accept that they have this property of being related to the content. So similar content will result in similar numbers. Does it make sense that we have this kind of functionality here, and we will use that to represent our pieces of text? Any comments, any ideas about that? Is it strange or surprising?
No.
Can I ask very quickly, the vector that we have here, does that represent the entire sentence or just particular words in the sentence? Because I have this conception that either a sentence or a paragraph be split up into its constituent words or chunks of words, or chunks of texts, characters, excuse me. Does that question make sense?
Yeah, thank you so much. Yeah. So one intermediate step, which is hidden from us and actually probably happens inside this call we had to a Java method, is about tokenizing the text. So our text is turned into a sequence of so-called tokens, which identify certain things, pieces of language, which are sometimes words or sometimes similar to words, depending on the way things are represented. So that is one step, which is probably maybe one thing you're referring to. So possibly a sentence of 12 words can be turned into a sequence of 11 tokens or 15 tokens, depending on what we have there. Sometimes it will include punctuation marks. Sometimes certain words will be split into double tokens and so on. So that is one thing which is happening. Thank you for mentioning that. Another thing that may need to happen is that if we have a very long piece of text, then we will need to split that into chunks and encode each chunk separately, because our model will not accept too many tokens. And at the moment, we don't have this situation because our text is very short.
Okay.
Yeah, thanks so much.
Thank you. Cheers.
Yeah. Any other thoughts, any other questions? Do we wish to discuss anything before we continue? Oh, I see some comments in the chat. Oh yeah, thank you. Yeah, so Ovi mentioned that there was a closure wrapper that does include some parts of LangChain4j. Yeah. Yeah, great. So we'll continue. And of course, this is the moment where already we don't understand what is happening actually, right? As usually happens with these AI models, already we have these numbers and we cannot make sense of any single one of them, of course, and that's part of the embarrassment of the whole situation, and that we're trying to get used to. Yeah, so we can embed. Can we try to extract? So I think, as far as I, from my previous practice, I see, this Java object we just received has a content member. So we can also do that with a threading macro, right? So we can, never mind. It has a member called content. So the content is the actual vector of numbers. And it is, you see, it is a Java object of class embedding, but basically it is just an array of numbers. Great. So we can create these. And now another thing we see in custom code is that we can add those embeddings to an embedding store. Right? So for example, after we've created this embedding store, we can add to the embedding store our vector, our embedding, with some additional metadata associated with it. And I think this part can be anything, but actually let us just have the text here. So maybe, let us wrap it this way. So let us say maybe our text is day is Saturday. And we add to the embedding store this pair of pieces of information. One piece of information is the embedding, the vector, and the other piece of information is the text itself. This way, in our store, we'll have these two connected. So when we did that, our embedding store is not empty anymore. So now we can try to retrieve something, right? So we can call find relevant, as Carsten did, with our embedding store, and do that with some other embedding of another piece of text, right? So maybe this other embedding we have will be the embedding of yesterday was Friday, right? Another piece of text. We compute the embedding of that piece of text, and we find the relevant elements in the store. Let us ask for 5 relevant elements. Of course, we'll not get 5 because we have stored only 1, right? Just to be sure, we create a store, an in-memory store in this case. We add 1 embedding to the store, and now we ask for the relevant ones. So let us do that. Okay, so we got this Java object of an embedding match type. Actually, we got a few of them, right? We got a sequence of them. So it is, sorry. Let us carefully check for the type of what we received. It is a list, right? So we can iterate over that. We can also count, right? So maybe let us call this matches. So the type of matches is a list. How many of them do we have? Only 1. It makes sense, right? We cannot find 5 relevant embeddings in our data store because it doesn't have any more than 1, right? And maybe let us print the first. So the first will be our matches. Let's take the first. And what is that? So the first is this embedding match object. And we see that internally it has the score that probably says how good the match is, right? The match between the text we were searching for about Friday and the text we did find in the storage, which is probably about Saturday, right? So the score is high. I think 1 would mean perfect match, right? The embedded is the piece of text. And the embedding, the ID is that, and the embedding is the embedding vector. So we can take the first and maybe just take the embedded member of that, right? So that's our result, right? We were searching for a Friday text, and the relevant text we found was about Saturday, which is, you know, the only text we had in the store. But now let us try to make it more complicated, right? Let us add a few other pieces of text and, you know, search for relevant things if it makes sense. But is it interesting so far? Is it, I mean, does it make sense at all?
Yes, yeah, it does.
Yeah, thank you. So yeah, maybe let us make it more elaborate. So let us maybe iterate here over a few pieces of text of a collection, and maybe in this collection we'll have these two texts and maybe another one. Tomorrow is Sunday, and maybe another text which is I'm learning Clojure, and another one will be what time is it? Right, so we have a few texts, and we will, you know, recreate the store and fill the store with these 5 embeddings. And I will ask for matches again. So maybe what we can do is search for a completely different thing, like maybe is it Tuesday? And now for is it Tuesday, maybe let us ask for 4 matches. So let us see what we get. Oh, not just the first. So maybe here, you know, we'll return a more informative structure, go through the matches, and maybe let's call it embedded. And for each match, maybe ask for the embedded, which is the original text. Right, so let us see what happened. We were searching for is it Tuesday, and we got these 4. And we see the first 3 of them were the most relevant to our question, is it Tuesday? And the 4th one was, you know, less relevant. Let us make it more detailed. So maybe for each match, we'll ask for the score of the match and the embedded text, like maybe text. Okay, so we see that these 3 were getting the highest scores of match. And what time is it? Is time related, but not about days. So it is, you know, it is farther from our own text. On the other hand, it is a question, and we were asking questions, so maybe it does have some, you know, benefit of being a question, right? So you know, we never know exactly why things are more or less connected, but I think intuitively it makes sense. We were asking a question about a day, and we were receiving first, you know, all the pieces of information which are about days. So that's the idea of embedding texts, representing them as arrays of numbers, and storing them and retrieving by similarity, right? So we were just searching for similar arrays of numbers, similar embeddings. Any comments about that so far? Do you think I should explore some more of this before we continue?
No, I think the concept's pretty clear at this point.
Yeah, thanks.
I think it's safe to move on if people agree.
Yeah, I agree.
Yeah, thanks so much.
Just a comment, like with a very cool use case for this, especially if we're gonna do this for elements of Clojure. If you're gonna have like in your Edit or a side assistant, you could give it the tool like search rag for Clojure best practices. So when it does something for the book find the correct thing and then implement it correctly. So that's a really cool use case, I think.
Oh, that is great. Yeah, so should we try? Oh, wow. Yeah, so let us try. So now I think we'll try to learn more of what Carsten did, you know, processing the PDF file and so on, right? So, right, I'm copying some pieces of code from Carsten's tutorial, right? So we have a document, maybe here, you know, let us call this embedding store 1. And now create another embedding store for our next experiment. And right, so that is how Carsten passed the PDF file. And here we'll pass our own PDF file, which is elements of closure. Oh. Great. So can we pass this? I'm trying to evaluate this piece of code. Takes a moment. Oh, did we fail? Oh no. Oh, IO, right. I should have like closure Java IO probably, yeah. So we can, you know, work with input streams and all that. So maybe I'm skipping a few of these details. Maybe some people are familiar with these, maybe some are not, but maybe that's not our core discussion today. So yeah, can we pass? I'm evaluating again, waiting for a moment to evaluate. Still taking time. Oh yeah, I did evaluate. So we have this document. What is that actually? It is a Java object called default document, which has a text member, right? So we can, you know, take the document and take text member of the document. That's great. And what is that? Just a string, right? Great. Great. So what do we do with that? So we need to split the text. Why do we need to split the text? We need to split the text because of at least two reasons. One is that our embedding model may not be able to handle a very long sequence of tokens, right? So a whole book might be much too over too much for our embedding model. The other detail is that maybe for a given question we may ask, not the whole book is relevant, right? If we wish to ask a question about, you know, closure lazy sequences, maybe only a few paragraphs of the book are actually relevant. So we want to split the book into parts and only retrieve the relevant parts of our knowledge base, right? We don't need the whole knowledge base as context for every question, right? So because later on we pass this context to a language model, which is also limited in the amount of context we may pass to it, right? So, and also for the focus of the context that will probably help the language model do whatever task we ask it for, right? So how do we split, right? So we see all these tasks, they are provided by this LangChain4j collection of classes. So we can split using document splitters recursive, which is a certain type of splitter algorithm. Let us maybe not try to learn it now. There are different methods to split texts into parts, and this is one of them. And I'll even not try to learn what the parameters that Carsten is passing are. Or should we maybe, yeah, maybe let us just for a moment go. So I'll go to the LangChain4j source and search for document splitters. This is the document splitters Java class, and recursive is one of these splitters. it tries to split the document into paragraphs first and fits as many paragraphs into a single text segment as possible. So, right, so it begins with paragraphs and then it collects them back into text segments. If some paragraphs are too long, then they are recursively split into lines, then sentences, then words, then characters until they fit into a segment, right? So there is some hierarchy of concepts here, and there are two parameters: max segment size in chars, right? The maximum size of the segment, which is the thing where we collect things back. Max overlap size in cars is the maximum size of overlaps between segments, right? Okay, so a certain algorithm, we may not learn the whole thing now, but we understand.
So quick question, is it just splitting sequentially, basically, text, the text of the document?
So it looks like it splits sequentially into paragraphs.
Mm.
And if it all goes well, at least by the description here, if it all goes well, then it just collects paragraphs back into bigger text segments. But if the paragraphs are too big, then it has to split further, and then it has another pass over those specific paragraphs which are too big, if I understand correctly the description. Right? Yeah, and one day it could be fascinating to learn about this and actually implementation. Maybe for today it will be distracting a bit, so maybe we should come back to our code, unless there is
Absolutely.
Yeah.
No, sure. Yeah, just curious. Thank you.
Yeah, I'm curious.
Well, I think just the ordering of the text and the data is important to the model itself. So I'd think that sequentially would be the way, you know, as long as the sequential nature of the data itself is maintained, because those relationships are important to the model. Is my understanding.
Absolutely, yeah. So there is that. The original or the problem trying to solve, it's the problem trying to search a large, I guess, corpus of text is that it's large. So the search space is quite wide. So that's why I was asking the question: is if you're going to split like this, is there some kind of index that they're just going to use to try to match, you know, your input text to some some section or block of text inside of the book? Yeah, I'm unclear, but I'm just thinking out loud. Yeah.
No, yeah, definitely. It's how knowledge is shared.
So. Yeah, for sure.
Yeah. So I think if we understand correctly, every text segment will be actually a consecutive piece of characters, an actual, consecutive, continuous chunk of our book. But between segments, we completely lose the order, right? Each segment will be an item of its own in our data store, as far as I understand. But at least in this split stage, maybe we get them ordered by the order of appearance, I believe. Let us try, right? So let us try to split. Can we split? Oh, right. So right, we need to pass the document, which is our book. Great. So we did receive a list of things. What is the type of that? Array list. And these things, it is an array list of text segments. And if we try reading them, right, maybe we should, let us call it texts as Carsten did. And if we, go through them and ask for the text member of each of them, then we should get a sequence of closure lines. Yeah, maybe let us truncate long lines. Yeah, oh, no. Yeah, so you see, it looks like the beginning of the book and then some continuation of that. So possibly, right? Possibly these are just, you know, text segments of the book. And we see where they break is not always the end of a sentence, right? It is sometimes somewhere in between, right? I think, right? Sometimes it is the end of a sentence. Great. So these are the texts. And now in Carsten's case, there was a need to clean the texts and handle the tabs. Do we have tabs? I'm unsure. I don't think we have many of these tabs. So maybe I'll skip this step of cleaning. Hopefully we don't regret that, right? It looks like we don't have many tabs. And so now we just embed them. We just, you know, run through all of them and make sure to include them in the document. But, oh, first we do embeddings. Okay, so no. Do we use embeddings here? Embeddings. Oh yeah, so why? Right, so possibly it is faster to embed many things all at once. I'm unsure about it, but it looks like that's the way Carsten did it. So we may follow this way. So first let us count all texts. 200, not so many. Okay, just 200. That's the whole book.
With this split version of the text. Yeah.
Yeah.
Must be fairly large chunks.
Yeah.
That
Yeah.
last text segment. Hyper reduction. Is it
I
the
remember Elements Disclosure is not that long. I'm checking right now.
Oh,
I could be
yeah.
wrong.
Yeah, that's, yeah. So,
It's, yeah. It's 120 pages, looks like.
yeah, so,
So.
yeah, going to the end, and yeah, happy reduction is the way it ends, right? Yes. Yeah, maybe that's the whole thing. And
Yep.
what we don't have maybe is the code, right? Do we have the code actually, or did we lose the code? Do we have any code in here? Yeah, we do have code. Great, great. So yeah, so we're maybe a little bit confident that it is okay. Great. So great. So now we follow Carsten's advice and just compute all embeddings. Let's see how much time it takes. Right? Maybe not so much. So yeah. So we compute, oh, right, because we don't have the cleaned texts. So I'm evaluating now, waiting for this to continue. Oh, yeah, so it didn't take much. And now we just need to make sure all of them will be in our data store as Carsten did. So we run over, first we collect these embeddings back with our texts. So we'll have pairs of things that looks like that. Every pair has a piece of text and a piece of embedding, right? Because we want to have these pairs included, associated in the embedding store. And then we just add them to our store. So let us run this. Did it? Yeah, so that was quick, right? So we have our, I should use embedding store too, we called it, right? So, okay, that's quick. Okay, and now we need to retrieve. So, right. So let us, maybe follow what we did earlier here when we retrieved something. Let us maybe retrieve some, some closure question and find relevant text segments for that, right? So what closure question should we ask? What is reduced? Is that good?
Yeah,
Should we try?
that works. Yeah.
So, oh no, all right, embedding store 2. Okay, so we asked for 4 text segments, and let us see how they look. So the first one says, if numbers has 1 argument in it, reduce will invoke our function. So the first one is related to reduce. The other one is similar. It's just a similar text segment. And right, so if we search for the word reduce in these, then it looks like reduce does appear in the text chunks we were finding, right? So it makes sense. Oh no, the 4th one didn't include the word reduce. Okay, so should we ask maybe?
Out of curiosity, well, actually, can we try either lazy or laziness? Because I'm interested to see if any results come back with the similar word. Like if we say lazy, does it just spell different from laziness? Will laziness come back with the result?
Yeah.
Ah, look at that.
Yeah, how can we highlight?
Right, so it understands the notion that lazy and laziness in a functional programming context are the same.
Oh,
right?
yeah. And only the first text segment was actually included the word lazy. And yeah, you were right. It did somehow understand. So that's for us the magic of embedding that. Somehow it's recognized that things are related. And the second one, does it seem related to laziness?
Yes. I'm reading right now.
I'm curious about the what level of association this tool can achieve at this point, since we're using that, I forgot the name, it's up there on the page, but we're using that language model embedded here in Scicloj. So if I can't find the book right now, but if I remember correctly, Zachary uses examples with stellar objects. I can't remember if it's planets or stars. Or there are some stellar objects in this book.
Oh,
Is it possible to
morning
do
star.
a really weird search on what and ask some I mean really silly question like what planets are available in Clojure to see if they would appear? He's talking about some philosophers and he's talking about but there's something with solar systems.
Yeah. What should I ask? So if I happen to mention planets, then I will just receive text segments which are related to planets, hopefully, right? So planets you know about, right? So let us highlight the word star. Does it? No, star. No. Highlight the word.
Yeah, that's the example with gravitational constant. Yeah, he's using that several times to stars or planets or things like that.
Jupiter. Oh, so it does recognize the relation to stars without mentioning the word planet or star. So that's nice. Yeah. Yeah. So should we now try to connect that with the language model? Or should we spend more time with the embeddings and so on?
We can go to the next step, I think.
Yeah, agreed.
I think we have 12 minutes to the official time. Some people may stay longer. I am glad to stay longer. And so maybe let us try to read something and just for the taste of it. And yeah, so, Oh, so this chapter didn't actually include the relation to the language model, so we may need to do that ourselves. All right, so how can we do that easily now? Maybe we'll use one of the Clojure libraries for language models. There is the Clojure AI. Yeah, oh, I think this one should be easy. So yeah, we'll add this to our dependencies. Oh no, this is not the one I was familiar. No, this one is a bit old, so maybe we should search for something. OpenAI Clojure is more recent, I believe. Right, so yeah. So we'll restart the REPL. And of course, we should be able to call a language model using LangChain4j as well. And maybe just for now, we'll not try to do it because I just imagine, first, we don't need to because we have good Clojure libraries for that, but also maybe it will be easier to use the Clojure way, right? So just searching for, oh, yeah, where is it? Oh yeah, this one, yeah. Right, yeah, so let us first see if we can call this. I think I remember how, right? So right. So first, just I evaluate the whole namespace once, just to make sure, you know, that everything is still running. Or hopefully, I didn't introduce any version conflicts or something like that, which I could, but yeah. So yeah, right. So oh yeah, was it okay? Oh no.
No, very good.
Yeah, I think it was okay. Yeah, great. Yeah, so right, so we can maybe try this. So here I just need to give it my API key. Open it. Oh, so I think it should be okay with my API key. I'll just try this now. It is an old GPT model in this example. It is okay. Okay. So this does work. Great. So now let us try maybe our question. What planets do you know about? And later we'll try to make this question a bit more focused. For now, I'll hide this guideline. Okay, so that's the usual GPT 3.5 response. And now we can try to inject more content, right? So let us write maybe, let's do something like that. So our question would be, what planets you know about? And before answering the question, we'll create more context. So in a moment, we'll have our content. And so we will find the relevant matches for question. Maybe 6 of them, I don't know. And after we find the relevant matches, we will just take the matches and map take the embedded text. can maybe join all of that as one string. And then we also add our question at the end. So question. So that will be our query, let us call it, or content. And let us first see whether this content makes sense before we pass it to OpenAI. And of course, you know, there are so many variations of what we're doing here. So maybe in a moment, one of you will try to propose something that makes more sense. But oh yeah, sorry. Question. Okay, so we got these text segments. Oh no, we don't want it this way. We want the text embedded segment. Right, so just the raw text. And here we have just this concatenation of certain parts of the book. And eventually we have a question at the end, right? And so that's what we have at the moment. And oh, maybe. Okay. So now let us just try to pass it to the model kind of stupidly and maybe see if that works. And so at the moment, you know, the additional context didn't change much, and maybe we need to find a question where the knowledge of the book is more, is actually can be helpful. Like, can you explain what a lazy sequence is? And then we get some response. Did it use the knowledge of the book? I don't know. So in a moment, we may kind of try to refine this and think whether we have some example of something where the book can actually be helpful, or, you know, how would.
Would you like another question?
Yeah.
Is the idea here to take the chunks of the text, have those serve as part of the augmentation of the augmentation to the LLM's knowledge base? Is that the idea?
Yes, exactly.
Okay.
Yeah. We use.
Here's a question. How would you effectively use abstraction and closure?
Oh, that's beautiful. That's beautiful. Thank you. So let us do that. Before we do that, let us just notice that the answer we got was about closure. So it was situated in the text that we added from the book, right? Because if we ask about a lazy sequence without adding the content of the book, right, like that, I remove that part, then we should not expect closure in the answer, right? So the answer was augmented to a closure book, right? But yeah, let us, can you say that again about the abstraction?
Yeah, how would you use abstraction effectively in closure?
And then you, I mean, since you were reading this book, you may say whether that sounds like Zach.
I'm trying hard to recall anything of particular from that book because he has a very philosophical way of thinking about it. But he, if I remember correctly, he prefer indirection over abstraction.
Oh.
Or you are in closure, or in a functional way, we achieve abstraction by indirection instead of bootstrapping the built-in abstraction from Java. So where possible, he kind of advocates indirection.
I see.
How would we do a query on that?
Yeah. would you prefer indirection or abstraction, and why? Please give an example. I would prefer both. Yeah. So first we should say here we are mostly communicating with GPT 3.5. Maybe we should replace that for a moment with GPT 4.04, and I never remember these names, but it might matter, right? So is it an actual name? I never know.
They have weird model names. I can never remember.
Yeah. Great. So maybe it is a moment where we should stop for a moment and oh, hello, Kyle and Jonas. Thank you for joining us. Yeah. And so maybe we should stop for a moment because we are around the official time. Some people may stay longer and keep going. And maybe what we should think about is what should happen next, right? And so I will try to upload this notebook to the Clojure data tutorials collection, and I'll publish the summary at the Clojureverse and in the Zulik chat, which is the main space for these sessions. And next session is 2 weeks away. Maybe I'll share the screen briefly just so that people can see that. So that's the Clojureverse where we post all our events as event pages, and next one will be 2 weeks away by our friend Kapil, and it will be Saturday as well, a slightly different hour, and so on. There is also another one through 2 weeks later, which will have 2 talks. So we'll have more sessions, and sometimes we'll also have these practice sessions. And maybe it is a good moment to think about what we may want to happen with these meetings. Do we like this format? Should we change anything? Should we bring any specific topics and so on? So that's one question I hope to ask you. And another question I hope to ask you is whether we should include whether we should publish the recording of this session. I think we didn't intend to make the recording public, but I think it was a useful session. So maybe that's one thing we may think about. And I think since everybody who participated, Nick and Brian and Henning and Timothy are all here, and I can ask Ovi later. So if it is okay with everybody, maybe I can make that public after some editing.
Absolutely, yeah. I find the recordings useful for myself. It's actually, I saw a previous one where you discussed LLMs, and that's what piqued my interest to check back and join this meeting. So yeah, very useful.
Yeah, great. So thank you. I see people nodding. And Nick, if you could tell me if that is okay to
sure.
Oh, thanks so much. Yeah, so I'm glad. So I'll edit slightly and polish some things and make it public maybe in a day or 2. And in a moment, we'll stop recording and keep chatting for those who can stay longer. And so I'm asking 2 questions. I'm asking one question, what we should do with these sessions, except for the talks, which are coming by a few community members. Should we have more practice? Should we focus on certain things more or less and so on? Is there anything we're curious about, especially, and so on? And so we have some time to think about it. If anybody wishes to say something before we stop the recording, any idea or proposal or comments or thought, then it is a good time. And otherwise, we will say goodbye to the recording and explore further. And to our friends listening to this video, please know if you join the meetings, you will have more of the discussion afterwards, which is the most beautiful part. Yeah. So goodbye to our listeners and see you on the next times.